All right, looks like we have all our speakers. So welcome everyone to the June edition. This would be our last town hall for this quarter. Hope everyone is starting off a good summer or ending one, depending, or for some people, it's, I guess, winter. We have a packed agenda as usual. We'll quickly go through project and community updates. Bunch of stuff happened in June. John is going to give a quick update on RBAC. I'll do a preview of the roadmap for the rest of 2021. I know it was a big thing for a bunch of folks in the community. And then we have three big blocks of talks today. The first would be talking about a recent work done by Harshal on adding query activity-based popularity data set, tables, pretty much anything using usage logs. And then the SAXO Bank team and ThoughtWorks are presenting how they have implemented Business Glossary using DataHub and what they're doing with it at SAXO Bank. Some very interesting stuff there with usage of schemas and protobufs. And finally, John and Gabe are going to walk us through improvements they've made to deployments of DataHub, both for single node as well as for multi-node deployments, a lot of simplifications. Community update, Acryl Data launched. We are the company driving the open source project forward, collaborating with LinkedIn and all of you. Of course, there have been some press articles, TechCrunch and a few other companies covered us. So do read about us. But more importantly, we are hiring exceptional engineers and community builders. So tell your friends and people who are excited about joining this community and building on the world's best metadata platform together. We're looking forward to the ride and the journey ahead. Other things, as I was thinking about kind of what distinguishes us from a lot of other projects or communities, I would say the engagement on Slack continues to be something that I'm blown away by, both in terms of the quality of people coming in, the kind of discussions we're having, as well as kind of the responsiveness of the community. So thank you to everyone. It's not just us. I know there's so many other people who help out when questions come up, whether it's design questions or just troubleshooting questions. So thanks for making this like one of the most vibrant communities that I've seen, and let's keep the bar high like this. All right, so let's move into more specific project updates. I wanted to give the floor over to Young to talk about some plans that LinkedIn have for the project in terms of Ember. Young.
Yeah, thank you, Shashanka. For those I haven't met, my name is Young. I lead our metadata and reporting teams at LinkedIn, so responsible for DataHub at LinkedIn. I want to give a quick announcement. I know there's been a lot of activity using the React client going forward, and so on the LinkedIn side, we also want to announce that we're going to deprecate basically the Ember code base. I think we want to just kind of have a call to action here to the community. If any folks are still using it, please reach out to us. We'll start a Slack thread, see if there's anybody using it, help folks migrate over to the React side, as we'll be doing the same on the LinkedIn side and contributing as well. And tentative timeline, I think, is probably in the next month or so. If we don't hear from a lot of folks, then we'll probably do it a little bit sooner. But we do want to give folks enough time in case there are folks that are still using the Ember side of things. So yeah, that's just a quick announcement from the LinkedIn side. Back to you, Shashanka.
Cool. That's awesome. I know that there's so many amazing features that have been built on the Ember side at LinkedIn, and it's always been a bit of a challenge to kind of build those same features in the React app. So I can't wait to kind of join forces and build these together in the future. So this is going to be great. Talking about releases, I held off on like minting the release just before the town hall because there are like 1 or 2 commits still coming in, but it's going to be called 084. It is not a backwards incompatible release, so we're staying with a minor release. I was looking at the activity that happened the last town hall. After that, we published 080, which was kind of the big no-code metadata release. Since then, in the past 3 weeks, we've had about 100 commits. So still keeping up with our 120 to 130 commits per month kind of rate. So that's pretty good news. There are a couple of RFCs that are in flight, and I wanted John to kind of walk us through the high level of what they're about and also give a little preview of what is to come on that front.
Yeah, sure. Thanks, Shashanka. So we have 2 RFCs that are currently open. The first one is about adding sort of the ability to collect user feedback inside of the DataHub UI and actually, read that feedback afterwards to understand how people are actually using the product. That's being driven by Melinda at the New York Times. Really excited to see what comes out of this. I think this is going to be a feature that really can benefit a lot of companies deploying DataHub today. The idea is, again, just basically being able to sort of trigger these in-experience pop-ups and small micro surveys and collect feedback on how people are using the app, why people are using the app, if they got the information they were looking for, etc. So I think this will be useful not only for operators of DataHub, but also as a kind of a source of feedback for the DataHub project more broadly to help us sort of collect aggregate insights and help drive the roadmap forward for DataHub. So looking forward to that. The second one is on the role-based access control side. This is something that a lot of folks have been asking for quite a bit of time. The last few months, we've heard it numerous times. The main idea here is we want to effectively provide a way to manage access to the metadata itself that's stored on DataHub. So this is not, access control for the actual underlying data assets. This is just access control to the metadata that DataHub has collected and aggregated on its graph. We have a design out. I think we just got some feedback this morning that was super insightful and useful. So we're still working through some use cases, some requirements and issues. I really would suggest that anyone who's interested in this, take a look at the design, go ahead and post on that PR, and we'll try to incorporate any of those suggestions. I mean, all the feedback we can get on this are very useful because we understand that every company has a different set of requirements, is operating under a different environment. So we want to make sure that we kind of collect that aggregate pool of requirements before really implementing this. Just for as a heads up, the target for implementation will be hopefully starting mid-July. So I do want to note that there's a timeline on this. So please do take a look at that. I think that's pretty much it. I don't know if you want to add anything, Shashanka, but otherwise, back to you.
Well, that's great. And I'm actually really looking forward to Melinda's work on the user survey as well. It's something we've talked about internally quite a bit. So yeah, call outs for the community. Please comment on the RBAC design. Make sure it addresses or will address the kind of complexity that you probably have in your enterprise, and make sure that by the time we get into implementation, we've got all the requirements locked in. Awesome. So a quick overall highlights on all the releases that happened in June. Again, broken down by the same typical categorization: product and platform features, developer and operations improvements, and integrations. So on the product and platform features, we're going to see a talk from Harshal later around how usage stats can really drive the product and what we can do with it. Second one is that we finally have Markdown descriptions and editing. This was, again, a common request. So now you can edit column level descriptions as well as dataset level descriptions using Markdown. So edit away. Third one, on the API side, we do now have a versioned API for metadata gets. So it was a little bit embarrassing, honestly, that DataHub keeps everything nicely versioned, but we didn't really expose an API to get those version metadata pieces back. So we added it. This is actually going to be the foundation for how we build schema history, as well as other kinds of visualizations in the future. No code has been hardening. So we released it in 0.8. Small stuff coming in, we're fixing those. And so, John, what do you think? Is it a 7 out of 10, 8 out of 10, 10 out of 10? Where are we? How hard is it right now?
I'm just going to be a salesman and say it's 10 out of 10.
I think there are a couple of issues still open that we're looking at, but I would give it like an 8 out of 10 right now in terms of how good I feel about it. I want to see a few more folks saying that we've tried it out and it looks amazing. We've got a few people saying we've got some small issues. So looking forward to getting more feedback around, are you trying out no code? How is it working for you? How many new entities have you added? Things like that. Moving on to developer and operations improvements, a lot of contributions have come in around hardening auth, which is great. So we've got new impulse for OIDC, improvements for Elastic Kafka. There's a GCP guide that Dexter wrote yesterday, which kind of completes one of our commitments to the community. We've got the AWS guide, now we've got a GCP guide, so you should be able to deploy on pretty much any cloud you want. And I think we'll have an Azure guide soon. Other big thing, Neo4j was a sticking point for a lot of folks, and we were considering moving to Neptune. But then, as we looked at the details of how DataHub is using the API and how the graph is built, we realized that actually Elastic can do just fine, especially for one-hop queries. It's actually a little bit faster. So we're switching the default. So Neo4j will always continue to be supported. And in fact, there might be more graph engines that get added, like we've heard interest in the community for dgraph. I know LinkedIn was about to move to Liquid when I was leaving, so that might have happened already. But on the default side, we're going to say you can just run with Elastic. So that simplifies your deployment. And in many cases, even your production installation goes much simpler. A lot of work has happened in hardening our Docker images. We were running on a really old base image, thanks to Grant for pointing that out, and we've kind of done quite a bit of work, and I think we're now all clear on the vulnerability side for all our Docker images. John and Gabe are going to talk about how much more improved single node install is now. I think they might be able to run it on a Raspberry Pi now, or it's one of our goals for this year, so that's definitely on the list. And then moving to integrations. A lot of work happened to integrate with Glue well. So Kevin has been doing a ton of work. We now support Glue both for S3. So like if you've got S3, there's a nice recipe for how to integrate with S3 datasets using the Glue pathway. But we've also got support for Glue jobs now. It was another thing that was asked right after we did the Airflow integration. Hey, we've got Glue ETL jobs. Can we get those ingested as well? So we've got that done. DBT, lots of features have been added on DBT. So we're getting better and better at the entire DBT graph, if you will. And finally, our first foray into ML. So we've got integration with Feast now. So for people who are considering using Feast for their feature store, this is a perfect time to try it out. The integration that has been done for Feast is only on the backend side. So the models are there for features, and then the ingestion is there. We have not yet built the screens for it. Just caveat there. So that's pretty much it for the highlights on the releases. And now the big thing, the roadmap for the rest of the year. So some of the stuff is carryover from things that we had promised we would do in the first half of the year. But a lot of this is new stuff that we are taking on for the rest of the year. I feel like we did a decent job of hitting our first half of the year milestone. It was pretty ambitious. There were a few things we couldn't get to, like data profiling and dataset previews or data quality integration, but we prioritized more of the foundational work, like the no-code metadata, simplifying the single node install and things like that, because we feel like that gives us the right base to build from as we add a lot of new features on top of the platform. So we feel good about the trade-offs we made. Big things that are coming up, as John said, are back. The implementation of that will land very soon. We'll start working on it, as we said, early July. Business Glossary, SAXO Bank will talk about it a bit later, but the way they've done it, it supports all of the modeling, all of the viz, but doesn't have the edits yet. So we're going to add the edits in Q3. Column level lineage, carrying over data profiling and SQL and dataset previews, data quality integration with a few systems, not just Great Expectations, but also AWS DQ and DBT tests. These are the systems that we find in our community. So the way we envision that integration to work is you can come to DataHub and you can see all of the data quality rules that have run, what is the status of all of them across all of these different tools. So it shouldn't matter whether you've got your tests written in one system or another system, you should be able to see it in the same way. And leading to that is, again, a foundational improvement that we're planning to make, which is building a metadata trigger framework. So what does that mean? DataHub is built for metadata changes, and a lot of metadata changes are happening in your ecosystem. So how do you react to those changes? And that's where the metadata trigger framework comes in. It allows you to listen for metadata changes and react to them. So this could be a workflow sensor that's waiting for a new partition to get added, or it could be something that's triggered when a schema changes, or it could be something that gets triggered when a quality result is produced, and maybe the data quality looks good today or it doesn't look good. The sky is the limit when it comes to all of the things that people can imagine they can build. And we're going to build a few of these, support for strongly typed event-based subscriptions to all of the changes that are happening in the metadata substrate. Of course, we'll build integrations with email, Slack, GitHub Actions, things like that are kind of the common ways in which people hook up things together. I'm very excited about that. I think it will open up, just like the ingestion framework made it super easy to get metadata into DataHub. The trigger framework will make it very easy for everyone to react to changes that are happening in the metadata ecosystem. And one final thing, a lot of interest in the community for adding the metrics entity. The LinkedIn folks are probably smiling because it was actually a very important entity in the LinkedIn ecosystem. We do want to put it out and provide it for the community, metrics with the ability to link it to data sets, dashboards, etc., so that you can search for weekly active users and you find the metric that describes weekly active users, and then you can find the data set that powers it and the dashboards where it is being represented. So that's all from our side, kind of committed for the Q3 roadmap. Moving on to Q4, a lot of stuff that we actually wanted to do in Q3, but we're going to do it in Q4. So if you want to accelerate this roadmap, let us know and we can partner with you on it. The ML ecosystem, getting features, models, and notebooks all nicely modeled and visualized in the UI. Support for operational metadata, so really supporting partition metadata, completeness, freshness, those kind of signals. Support for the data lake ecosystem, so support for the common formats out there, Delta Lake, Iceberg, Hoodie. Hive already supported, so I'm not including that here. And then I don't know how many of you attended Data Mesh or Metadata Day. There's a lot of interest in supporting data mesh oriented features. And I know a lot of our companies in the community are actually implementing data meshes. So being able to support those kind of features in the product, like being able to see a data product on its own, separate from a data set, being able to see analytics on how is my data mesh journey going and improving as we go, like what percentage of my data products are being driven by high quality data sets or vice versa. And then finally, collaboration features, being able to share knowledge across all the data professionals, and then having conversations inline in the product, as well as off platform. So those are kind of our Q4 roadmap items. So that concludes kind of the project section and the community update section. And I will hand it off to Harshal to talk about dataset popularity using query activity.
Awesome. Thanks, Shashanka. Do you want me to share screen? I think that might be easier.
Okay, why don't you do that? I'll stop my share here.
Okay. So I hope everyone can see this. Yeah, so I'm going to be talking about dataset popularity and how we use it in DataHub, as well as how we get it from query logs and query activity. So first off, why do we care about this? So for different people, data set popularity implies different things. For the data platform owner, it enables them to kind of understand what's going on within the enterprise. How is data being used? In what systems is it being used? If you've got like a Snowflake and a BigQuery, let's say, and you want to understand which one is actually being used by more people and is more popular, you can understand that using popularity and usage logs. It can also help point you in the right direction for where to dedicate more resources and where to, both in terms of people and in terms of compute power, so that you never have an issue as you operate. For data engineers, data popularity is a little bit different. For them, it kind of helps them understand how are people using the things that you're producing. So kind of like an impact analysis within the company, as well as helps you prioritize among the data assets that you actually produce, which ones are most important, and which ones are actually getting used, which ones say could use more documentation to improve usage, because it's a great data set that you produced. It can also help you streamline the deprecation process. So let's say a data set that you're trying to deprecate still has 100 queries a week. Well, then you probably don't want to deprecate it just yet. Instead, you want to look at the popularity and the usage, figure out who exactly that person is, and reach out, help them migrate to a different solution. For data scientists, popularity and usage is a major trust signal. It helps kind of understand, is this thing someone that someone put out a year ago and hasn't touched since, or is it something that is being regularly updated, regularly used, and is something that you can rely on, given that other people are also relying on it. The other thing you can do is you can look at kind of the other queries that people are issuing against that data set, figure out, say, what other tables are relevant here, what is it commonly joined on, which keys, and so forth. So you can kind of determine not just whether or not to, but also how to query that data set. And then, helping everyone is, we can use usage and popularity data to improve search rankings and, improve the ordering of things and the lineage visualization and so forth. So lots of product improvements for DataHub can also come out of the usage statistics. So let's look at what we're collecting and kind of how we're doing that. So right now we support BigQuery and Snowflake for usage stats. BigQuery, we're using the BigQuery logs and we're parsing those out. And then with Snowflake, we are using the access history and the query history views, joining these together and getting our popularity and usage data that way. And for each data set, we can collect per user usage frequencies. So, person A is using it this much, person B is using it this much. We can also collect how they're using it, what queries they issued, a lot of granularity here, even to the extent of what columns are they frequently querying versus which ones are not being used. And once again, we kind of roll this up and can get frequent queries across all the people using a given data set as well. So how did we design this? I want to talk about this a little bit. So some of the constraints we were pushing against, scale wise, it wouldn't be unheard of for a company to be issuing 500,000 queries per day against, say, BigQuery or Snowflake or a similar data warehouse, and have 10K users. So this was kind of our North Star on what sort of scale we might want to support. They'd want to retain a decent bit of historical data so that they can view this historical usage over time. Let's say a year here, but it varies for different enterprises. Some might only care for 30 days, some might care for many years. And the last thing is we want to avoid refetching the same data from the same source system repeatedly. What this means is, if we're collecting data, we only want to pull that given piece of the usage log or the query log or whatever it is once, and then not have to pull it repeatedly. So given this, some of the decisions we made. The first is we're going to start with a batch-based system. So you can configure it to run hourly or daily, whatever you'd like, and we'll pull kind of the most recent queries in history that has happened in that past time period, and then we aggregate it during ingestion, because this data at the top level of scale, say if a given log event is 2 kilobytes, this reaches a gig or so in memory, which we probably don't want to do. So we have a memory efficient algorithm for kind of pulling this in while preventing the memory usage of ingestion to blow up. And then we do some pre-aggregation here on a per data set level, roll it up so that we get frequent users of a data set, frequent columns used of a data set, frequent queries of a data set. And then we take that information, we can push it into through GMS into Elastic. And that's where we can store these aggregated statistics, do additional aggregations on them, and then surface them in the UI as you might expect. So,
Marshall, I guess one more interesting constraint in the design that you probably had was not adding one more moving part to DataHub, like, oh, you've got to go run a Spark job, or you have to go run some other big data processing job to compute this stuff, right?
Yeah,
I think that
absolutely. And that's actually kind of a good segue into the demo piece. So I wanted to show how BigQuery and Snowflake usage work. The Snowflake one, I'm actually going to show you how it's looking when scheduled with Airflow, because that's kind of the common use case here. You schedule it on a daily basis, and then how it looks in the UI. So we can start with how BigQuery usage works. So right now I have a little recipe configuration. It works the same way as most of the other sources do. You just have a new plugin type called BigQuery usage. You can put in the project ID for BigQuery. I just have a playground instance that I'm using. And I unfortunately haven't queried this instance in a few days. So I just reverted the start time to the beginning of this month. And then here we're just going to dump it to a file instead of pushing it to REST as you might normally do. And simply running it as you might expect will take a little bit to pull all of the data. So what is it doing here? It's pulling the BigQuery usage logs from the cloud logging product from Google, and then doing a little bit of pre-aggregation here, and then dumping that into a file here. Cool. So this might take a little bit because the time range is quite large. There it is. Okay. So you see a couple instances. We can see the general queries that I was, or the general data sets that I was using. And then if we want to, we can take a more detailed look into the actual usage data that was produced. So we have, emails, frequent queries, and then the fields and each one of their usages as well. And we have this on a per day basis, per bucket, or per data set basis. Cool. So at Snowflake, it works pretty similar. I actually added it to our demo instance here. It's pretty straightforward how it looks. This time we're running the ingestion using direct code because we want to do that inside of Airflow. And it's remarkably similar. We first ingest Snowflake, and then we add Snowflake usage in kind of a pipeline. So you get both of them at once. Once again, kind of set your configuration. And then I wanted to get a bunch of historical data. So I set the start time manually. But then beyond this, I might just leave it blank and it will automatically do the current day. And yeah, now that we've kind of run this successfully, we can see the little green box there. We can head over to the demo instance and we can see where this is surfaced in a couple places. So the first is we see immediately the queries, that the number of queries that have been issued against this data set. We can see that it's 78 in this time period. And we can also see, I and Swaroop have issued queries against it. And so we can see the top users, and this is going to be ordered by frequency. So you know that, I've done the most and Swaroop's done the second most. Beyond that, we can also see, per column, so entity and earn, these are the two columns here. We can see the entity has had 78 queries per month, and the earn field has had only 43 queries per month. So we know that, people maybe use the entity field more than the earn field for whatever the reason might be. And what might that reason be? Well, we can actually hop over to the query instance, and we can take a look at some recent queries that have been issued that reference this table. So, your standard select count, group by entity. Here's where we might guess that the entity field is being used more frequently than the earn field or other fields. And then we can also see people are creating other generated tables that reference this all entities table. So we can kind of understand how are people using it, how they're joining on the earn, and so forth. So we get a lot more rich information about how people are using this data set. So that's it for the demo. I want to hop back over to talk quickly about what's next here. So obviously we're going to iron out the edge cases and figure out any issues that we might have. We're going to integrate usage statistics from more systems, so expanding beyond BigQuery and Snowflake, as well as getting more rich integrations of this usage data into the search ranking, lineage viz, and so forth. With the UI improvements, we've got a bunch of time series data for the usage statistics, and right now we're kind of only showing queries per month or something. We can also add line charts so that if you're expecting a certain, say, data set to be deprecated, you're going to look for the usage per day to kind of taper off as you migrate people over. And then finally, expanding our time series metadata piece to add mechanisms for using no code to like using a similar no code approach to expanding that. So yeah, with that, love to hand it over to Shashanka.
Awesome. Thank you, Harshal, for that. Yeah, if people have questions about how to use it, my first question was, why is Snowflake and Snowflake usage two different sources? And there's actually a good reason for it, because in some of these sources, the place where you get usage data from is actually different from the place you get the metadata from. In some cases, you actually need elevated privileges to get usage data out. So it makes sense to separate out those two pathways. One of the things I'm also very excited about is how simple we have managed to keep it so that it's still the same deployment footprint that is able to also pull out usage logs, and it doesn't kind of overwhelm the system. Once we add time series metadata support for no code, I think it'll be pretty cool to see different kinds of systems being able to push usage metadata into DataHub. Awesome. So our next talk today is Sheetal and Madhu, who are going to talk about Business Glossary and their implementation of that in DataHub, as well as at SAXO Bank. So Sheetal and Madhu, you want to take it away?
Yeah, Shashanka, I'll start quickly. Am I audible?
Yes.
Yes.
Yeah. Thank you, Shashanka. So quick context, SAXO Bank, along with partnership from ThoughtWorks, Madhu as a data strategist from ThoughtWorks, we were working together in an engagement, and we have contributed back to the open source on Business Glossary, work closely with Acryl and LinkedIn. I had the data integration and the data governance tech platform for SAXO Bank, and we are developing an in-house data management tool, which is based on LinkedIn DataHub and Great Expectations. So quickly an update on what we have done. So what is Business Glossary? It is a list of business terms, which is a glossary.
Sheetal, you want to share the screen?
Oh, I thought I've already shared. I'm sorry. Okay, let me know if you can see my screen.
Yes, we can see.
Okay. Okay. So brief theoretical context on Business Glossary. Business Glossary is a list of business terms with the definitions, which lays down business concepts for an organization or an industry and is specific to a database or a data store. It's a glossary of business terms. It enables the organizations to define a common vocabulary. We are a financial industry, so we are inspired by FIBO, and we'll take often an example of FIBO, but the glossary that we've created is like an aggregator which can expand apart from FIBO to other ontologies specific to the industry, as well as provides the ability to create a organization specific for us. It's SAXO specific glossary as well. How does it help us? So once it is out, it helps us to identify the relationship between different terms. This is an example from FIBO. Eventually, we want to target graphical representations, but we'll stick to tabular on DataHub or our Data Workbench product. I'm just laying down the pain point which led us to come up with this solution while we kind of developed this. A couple of years back when we started on this journey in SAXO Bank, and I was taking persona interviews across the organization to understand the pain points around the data. The common problem that came from different system owners and system SMEs was data quality issues and inconsistencies, where they were spending a lot of time solving tickets because of data flowing across systems. A quick example, and it's a very common example, I have a data set A in system A, data set B in system B, and data set C in system C. And if I got a few data elements where account in system A, data set A, the account name is named differently in data set B, account number, they're same things. And in system C, it's account ID. So the ETL that flows from data set A to B is dependent on the mapping sheet that is being created by system A and B. And similarly, ETL from data set C to system A is dependent on mapping sheets too. If the SME leaves or some knowledge is going here and there, and another version of mapping sheet 2 is created, the ETL process is screwed up, validations fail, and account ID and account name are no more consistent. And then this leads to a lot of issues. Now, how can we resolve it, right? Can we remove the dependency on the mapping sheet and enable this or expand the maturity of the schema so that we can use a common ontology, business standard ontology. In this case, this is the FIBO account definition. If we can point all these account names, account ID, and account number across these systems, expand the schema, then being ingrained in schema, the dependency on the mapping sheet goes away, the dependency on the SMEs go away, and the data flows across systems can be consistent, can be correct. Quickly, how do I enable it? So what we have done is, if this looks familiar, this is the data hub page where we have added tags and terms, and these are the business terms which expand the metadata for the data elements. And this actually, and we'll show it later, this actually points to the FIBO URL or whatever you have chosen. It could be FIBO or anything else. Then the design principles that we have stuck to is we've stuck to data ops principles, which is based on communication, collaboration, integration, automation, and measurement. we believe that business glossary can be evolved, staying agile, iteratively, taking care of business needs. In the digitization journey, this will and will also show in the end, if we get time, how we wanted to make sure that technology is involved right from the start when a business function is introduced into the organization. Enhance the metadata. So apart from the data elements, now will also have industry standard ontologies defined at the metadata layer. Obviously, schema maturity, because the business terms are now ingrained in the schema. Schema versioning, any changes into the metadata regarding the data elements, data types, or business terms will cause the schema to be versioned. And it will enforce ownership not only of the metadata, but also of the business terms, their appropriateness and validity on the producers. Quickly, how we have actually realized the physical implementation, both for data sets and for business terms, our schema definition is in Protobuf. So the messages which are defining a business terms use options to define the type of the business source, that ontology source that we're using, and their URL. So with this, I'll quickly stop sharing and hand it over to Madhu for the next set of slides and the demo.
Thank you, Sheetal.
Yeah, I'm just 1 second.
Is this screen visible?
Yes.
Yeah. Okay. Thank you, Sheetal. Connecting back where Sheetal talked about business terms, like define the business concepts, enable the common vocabulary within the organizations. So I wanted to talk about how we are trying to relate the data sets with the business terms that can enhance the value of the elements and maybe better meaningful to the data sets. I've taken a simple example where the purchase order, which has these elements, which is ID, revision number, status, employee ID, vendor, a number of elements. We have order line item, these elements. Now, if I talk about like vendor ID to map to the supplier identifier, maybe another table we call it the product supplier ID and map to the supplier identifier, this actually enhances the value to this data set. And other byproduct is if you define a certain business rules at a supplier identifier level, you can actually drive those business rules against these data sets. And other than association of the data set, which is enriching the value of the data sets, business concepts or terms itself is interrelated or like and hierarchical. So some of you can compose the business term and create a new term altogether. Let's say we have a purchase order date, value, and ship date. These are part of like composed and created the purchase order. That is the kind of relationship will help you to discover your data sets of interest and get to the right data set. So with this, I'll just move on to the next step. How do we bring this business glossary into the LinkedIn Data Hub? I think left side is the one which is very much familiar to you, everybody, which is the data set, one of the first and foremost entity. So you have these aspects, ownership, schema, metadata, and all those things. Now we're trying to bring in business term or business glossary, which is a third with these two entities. One is the glossary node, another is the glossary term. The glossary node is introduced to define the hierarchy of the ontology. Okay, so we could achieve very much similar to the FIBO kind of hierarchy. If I want to relate this analogy, right? Okay, glossary node is kind of a package. You can have a number of hierarchical levels, and glossary term is a class definition, which talk about the business term. Okay, if you can say glossary term no info, this talks about the definition of the glossary term and source of the term, which can borrowed from. It can be internal organization, it can be borrowed from the external organization, and you can even have a link to the external organization so that people can navigate. So this is the first thing. We onboarded these entities. Then we had expanded the data set by adding a new aspect to the data set so that glossary term can be related to the data set. And data set has a schema metadata, which is an array of schema field. We enhance the schema field to associate the business term at the attribute level. With this, you are able to attach the term to the data set and the schema field that help the business user to navigate to the data set from the business term concepts itself. The one other thing which currently we're working on the design is the terms itself are related, which we have seen in the previous example as well as Sheetal given, that we are achieving to the another relation which is established within the terms. It can be is a relationship and has a relationship. So with this, I'll actually try to move to the SAXO implementation so that you'll have better context how we actually implemented. These are the simple templates we use. The first is the dataset definition. Okay, in this case is the Kafka dataset, Kafka topic we are onboarding. So you can see the name of the topic and there is a schema associated. This is one of the enforcement done at a SAXO. Schema is a mandatory thing. And there are like ownership, business, technical, and data steward ownership. And right side, you could see the schema definition. Here, the schema is savings account. This is again a fictitious example. If you see, like there is a type name and there are attributes like account number and the balance. If you look at the balance itself is another type, which is the balance amount. And I would also see, you could also see the savings account is kind of a link to a customer account. Here we're trying to define that. Oh, you see savings account. This is of a term or a type customer account, so that you are able to relate things, so that you can, okay, even though let's say example, like in an organization, your independently terms can evolve over a bit and realize that these are common. You can relate it back. And Proto given a very flexibility so that you can actually expand the definition or metadata of a schema. We are using an options to do that. And there are other cases like, okay, if you wanted to attribute classify the information classification as a personal or a confidential, you can do that with Proto much easier. And the same thing can be used to drive the other business rules. So next thing is, I wanted to give a little broader view of how the metadata is onboarded. SAXO has adopted the data mesh approach to the new data platform, where domain teams are responsible for building the data products and also annotate about their metadata. So they're responsible for like come up with the self-service capabilities where users can be declaratively define the data set, and we have a GitOps process which takes this thing and create the topics in the Kafka and reaches the schema and extract the this metadata templates, parse the files, and pushing into the LinkedIn DataHub by converting into a snapshot which is required by the MC schemas. With that, I'll quickly move to the demo in the interest of time. Here you could see this is the SAXO, we call it the data workbench, is a one-stop shop for data. So you see the home page of the data workbench. Let's say, let me take it to the business glossary. And these are like, we have a domain hierarchy, party domain, market domain, and trading and common these things. And let me take a simple example of here. Okay, we could see a customer account. Earlier we have seen the example. I could navigate, either I can search through or I can directly go here. If I go to the business term, I could see the definition of the term and what is the source, and I can navigate to the source if it is an external definition. It points to the FIBO here. It can be other things. And you could see the related data sets and additional properties, right? With the related data set, you have two data sets. Maybe you can navigate to one of data sets and see this is the very much familiar to everybody. So which is the data set homepage where you have information. Now you could see this is mapped to a customer account as a business term with is a relationship. You can say this is a customer account and has this terms UID and balance amount, and one can navigate to these definitions and get into the lot more details. So with that, I will hand over back to Sheetal.
Shashanka, I'll just check. Do we have time, or do you want to skip that?
I think I would like to let John and Gabe also go through. So
Yeah,
maybe
let's go ahead. Yeah.
Cool. Thanks, Sheetal and Madhu. I think we've heard multiple times from the community, a lot of folks who are implementing similar practices in having their schemas checked into source code along with metadata annotations on top. We did the same thing even at LinkedIn, but it's really nice to see a lot of companies are doing something similar. And it's great to see some of these recipes emerging for how to connect schemas in Git along with metadata in Git, along with this kind of push-based architecture to get metadata out and integrate it into a common base. So I would highly encourage reaching out to them. We probably are going to have similar support for even in the open source code base for having Protobuf schemas and applying annotations on them. And so to talk to them about how they've done it and try to implement similar practices at your organization, I think it's definitely a game changer. Cool. So next up, we have Gabe and John, who are going to talk about all of the hard work that has gone in simplifying the DataHub deployment, single node as well as multi-node. John, do you want to share the deck on your end, or do you want me to walk through it?
It's just a couple slides. Do you mind just sharing?
Okay, no worries.
All right, thank you, Shashanka. In the interest of time, we'll keep it pretty short to allow some time for questions at the end. Yeah, so in the past few weeks, Gabe and folks from Acryl have been working on simplifying the DataHub deployment. We've heard from the community that it's very heavyweight, and surprise, we agree. So we're trying to do everything we can to simplify it along multiple dimensions, including sort of the resource consumption, the overall complexity, and beyond. So if you wouldn't mind, Shashanka, going to the next slide, I'll start talking about what we've done. So there's two kind of broad buckets we improved over the last few weeks. The first one is really just the general experience of deploying DataHub for the first time. We believe that you can get a lot of value out of DataHub just from the default models, kind of the boilerplate implementation without changing anything. So as part of that belief, we decided to kind of allow you to deploy DataHub without actually requiring to check out the code. So previously you had to git clone, cd into the Docker, quick start and run that script. Now we've changed it up so that you can just install the DataHub CLI and go ahead and run DataHub Docker quick start. To ingest sample metadata, you can just run DataHub Docker ingest sample data. And it's really nice. What we do behind the scenes is we go and we fetch a few files dynamically, a full Docker composed file that includes all the default environment variables you would need to spin up everything. As well as some other resources, and then we go ahead and deploy it. So we've updated the quick start guide to make this kind of the default mechanism for deploying DataHub now. We've heard some feedback, fixed some issues, and I think recently things have been looking really good on this. We're again trying to push down the barrier to entry to actually deploying DataHub for the first time and minimizing that time to value that we can provide with DataHub. So the second thing on the experience side is that we worked on improving the logging coverage. So this is another ask that we've heard from some of the community members, as well as operating DataHub ourselves. We realized that we're just not as we don't have as much coverage as we need. So we added a ton of info error debug logs in both DataHub frontend and in DataHub GMS. We also set up the kind of log rotation default settings. So we have all of the info error warning messages going to a normal daily rotated file. That can be found under /temp/datahub/gms or /temp/datahub frontend. I think this is going to be really useful, especially for us providing support to the community. I think now we can just ask folks to go and create a zipped log file and send it over when they have issues. So it'll greatly improve our own ability to help you guys. The second thing is we've added a ton of debug logs that will not be part of those logs by default, but we've added a short-lived sort of like memory capped debug log as well that rotates every day. So that's going to be a lot richer. It has information that's really specific to DataHub's application. So we kind of filter out the other logs and only log DataHub stuff. So hoping that'll help us, debug those critical issues much quicker in the future. Just note that PR is in review. So if you guys want to take a look at it, that would be greatly appreciated. The second thing is on the resource side. So previously it required, 2 CPUs, 8 gigs RAM, and 2 gigs of swap roughly to deploy DataHub on Docker desktop or using the Docker engine. We were able to get that down to 1 CPU, 3 gigabytes of RAM, and 1 GB of swap. I think we can, to answer Shashanka's earlier question, we can run it on I think it's the second tier model of the Raspberry Pi now, which comes with 4 gigs of RAM. But again, we're continuing. This is going to be a continuing effort. We're trying to push that really as low as we possibly can. Again, this is something we've heard from the community. It's just too heavyweight. It's kind of annoying to have to go and change those Docker settings all the time and debug that stuff. So big progress there. The last thing is just the actual container count. So previously we had shipped DataHub Quick Start with a lot of sort of miscellaneous tooling to help operators of DataHub, but we found that most operators were not actually using this tooling. So things like Kibana, the Kafka REST proxy, some schema registry UI, things like that. So we've just reduced the number of default containers we're shipping with, and this is a work in progress. I mean, you're going to see us over the next few months continue to try to work this down. I think we have a few areas we can improve, specifically on the DataHub containers themselves. We're hoping we can actually merge GMS and the front end into one container in the default case, of course, allowing you to deploy them as separate containers as well. But one other big thing we recently did, which some of you have already discovered, is we merged in the two Kafka consumer jobs we had, MAE consumer and MCE consumer, into GMS. So that's all now one deployable by default. So that gets rid of 2 containers, which we think has been a great improvement for at least for us operating DataHub. So excited about that. We're going to continue to try to work on that. But one last thing I'll just call out is with the DataHub CLI Quick Start, it's a lot more resilient than just running quickstart.sh, mainly because we've provided this kind of wrapper that will actually check to make sure that all of the required containers are up and are healthy, as well as pinging them, things like that. And so I'll conclude with the little message that we added there, which gives you a green DataHub is now running when you deploy. It's very satisfying to see, especially if you're coming from running the quickstart.sh world. So with that, I will pass it off to Gabe, who's going to talk about simplifying our persistence layer.
John, can I ask one question that I heard from the community as well and has come up a few times? The Docker Compose files that are sitting in the the Git repo, are they still usable? So can I still go into them and just do Docker Compose up, and will that still work?
Yeah, it'll still work. The big change we made there is actually splitting some of those tools that I had mentioned into a separate Docker Compose file. So you certainly can deploy kind of the thin version, as well as adding that additional tooling if you want it pretty flexibly. So we haven't really regressed in functionality, right, or what we're supporting. We've just made the default kind of much slimmer. But yes, all of those Docker Compose files should still work. Got it.
Another question we often have gotten is, with this merge of MAE consumer and MCE consumer into the DataHub GMS, does that take away from the flexibility of being able to run those consumer pools separately and scaling them out independently?
No, so actually we still are going to be publishing independent containers for MAE consumer and MCE consumer. And you can configure your deployment using environment variables. So you can actually switch off in GMS, the MAE consumer and the MCE consumer, and then go ahead and deploy those MAE and MCE dedicated consumers if you are operating an environment where you need to scale those different services independent.
Okay.
Yep.
Cool. Awesome. All right, over to you, Gabe.
Awesome. Thanks, John, for sharing all that stuff. I'm really excited about how much easier it is to start DataHub now. And I think folks are going to find that it's just so much easier to get things started. Shashanka, if you go to the next slide. Yep, we'll talk about one other way that we've made it even easier to deploy DataHub. So one thing that we've heard from the community is that sometimes Neo4j can add extra complexity when running DataHub, and some folks want to be able to run without Neo4j. So we've provided the option to run DataHub just using Elasticsearch as the backend for our graph service. So we've essentially abstracted out the different graph methods into an interface, and we allow you to run that either with Neo4j or Elasticsearch. Right now, DataHub just uses single hop queries to power the front end. So Elasticsearch and Neo4j are going to be about equally performant. In fact, Elasticsearch might be slightly more performant in some cases. Some folks are going to want to do more advanced graph queries, and also we intend to add more advanced graph queries to DataHub down the line. In that case, for very large graphs that are running very complex graph queries frequently, you may still want to use Neo4j. However, for many deployments, Elasticsearch will continue to be just as good of a solution. So if you want to go ahead and remove your Neo4j dependency, you can go and start using Elasticsearch as your graph service backend today. So we've updated the Helm docs to give you instructions on how you can use Elasticsearch as your graph backend. It just requires flipping a variable on which graph service implementation you're using, switch that from Neo4j to Elasticsearch, and then disable your dependency on Neo4j in the Helm prerequisites, and you'll start using Elasticsearch as your graph backend. So soon we'll be providing migration scripts so that you can re-index your Elasticsearch graph backend with the existing data that's in Neo4j. For now, if you want to get those relationships, you'll just need to re-ingest the data.
And Gabe, are we running demo.datahub on Elasticsearch now?
Yeah, we are. So if you want to go ahead and just see how performant things are, you can go to demo DataHub and you'll see that relationships load essentially instantly. And I think you'll find that in many cases, Elasticsearch is going to be just as good as a graph service backend. But moving forward, we're going to be we're going to be continuing to support both of them. And if you ever want to add your own graph implementation for a different graph service, you can implement the graph service interface with any graph database and contribute that back. So it doesn't have to just be Elasticsearch and Neo4j, it can be any graph database.